right, I guess the doors are closed, so there's no time like the present. Is everyone able to see the two links down the bottom? I realize that red on black on a large screen is a little bit tricky to see. But let me just get started because this is long and I'm going to be talking very fast. So every talk has an intro. This is mine. Look, many forewords in this talk. I wrote most of this talk during the uni drama, and normally preparing a talk is something I love doing, but I really struggled with this one. There was some depression. I lost a lot of time. So this is going to suffer in terms of quality in some places. I really hope this is useful to people, even if for some of us, the current game we're working on may be the last one we do in Unity. So who the fuck am I? I'm Kiera Lord. I also go by Cratesmith on social media. I worked on a bunch of games. I am a programmer mostly. I've done lots of other roles. I was recently at 5 Live Studios, downsizing a code very recently, so that's not true anymore. So what you should expect from this talk? Well, this talk is exclusively about the Unity editor. We're not going into builds at all. And also that most of the solutions in this talk are what I describe as brittle. They're the sorts of things that will break between Unity versions, and they're things that you will need to maintain. So you need to sort of accommodate time to work on those and not have too many of them. And also they're not very good for maintaining for third parties or externals, like external parties. Secondly, this is not a talk where I go and tell you a couple of examples and you're supposed to think that I'm really cool. I'm trying to go through and show my process, and I'm hoping that you can find your own process from that, or maybe my process works for you. The examples I'm going to show you are not full drop-in solutions. They need some elbow grease to sort of make them really nice to use, but I had to cut them down in some ways to fit them into this talk. So that's that part. Finally, I'm going to swear a lot, and there's going to be a lot of spicy hot takes. I'm not presenting any of that stuff as fact. There's going to be my opinion all throughout this talk, and there's a lot of pent-up vitriol. So let's get right into that. Trans rights are human rights. Housing is a right, not a fucking investment. There is no such thing as a good billionaire. Fossil fuels are killing us. Can we stop and say it with me? Fuck you, John Riccatello. Yeah, that felt good, didn't it? So why am I doing this one? Well, in 2016, I did a talk about how Unity had become harder to use, more confused, and less productive. And at the time, I was really optimistic things would just turn around eventually and improve. I was, how should we say it, fucking wrong. So here we are now. Unity has gotten much more difficult to use. Everything is in packages with versioning that I can best describe as chaotic. New features are just a bit rough. They are often years before they're even usable, like whichever Unity UI toolkit we're up to now. And in some cases, I just don't have faith that they're anything more than marketing, which is the case of Dots. If you want to hear about that after the talk. So why did we get here? Well, Unity's core business model stopped being about games. It's now about advertising in other industries, military, gambling, and also they're a publicly traded company. There's a lot of other things which are happening. They don't build full games internally in their engine, so they don't know about these problems until we start screaming, literally like I am now. So the other thing is that whole public thing happened. They went from a small team with an incredibly dedicated direction to a workforce of over 7,700 at last stat I saw, and a lot of the senior core developers who were driving that original direction have left, citing major disagreements with where things are going, which means that no matter how good the people who are there are, you've got 7,700 people running in different directions. And this just feels too goddamn familiar. You see, I was working at Pandemic many years ago. I'm much older than I look. And it died in a giant growth spiral when our new CEO merged us with BioWare and sold us to EA. That CEO just happened to be John Dev's a fucking idiot's Riccatello. Now, he's not solely to blame. There's rumors that have come out which indicate other people have caused damage too. But they're not acting in the interests of the product or the people who are using it, as far as the game developers using it. So, please be kind to the people who are working at Unity who aren't in the executive level, because no matter how bad it is for us, it must be so much more difficult right now with all the stuff going on. So just that. Okay, so now, once I've gone through that, honestly, that was something I just needed to yell at a crowd. My approach to talks, if you haven't gotten on this already, is very fast, very technical. I'm not aiming for you to understand every single thing and remember every line of code. I just want you to get a high level. There is slides. These slides are online right now at that link. There is a full Unity project with all the source code here at the other link, including a tiny test game for you to play around with. So don't feel like you have to take notes unless there are questions. Don't feel like you have to take pictures of every single slide. We're good. Okay, so let's ease into what we're doing and kind of talk about why. So Unity is, underneath all those problems I screamed about a moment ago, kind of like, it's still by and large a good development environment. There's just a staggering number of omissions and key features that just have never been fixed. And the aim of this talk is to demonstrate that no matter what, if you need a feature present that's elsewhere or you thought it up, nobody can stop you adding it to Unity, no matter where it's in, like where the thing is you need to change to have it. So let's start off without actually doing too much damage. Let's talk about Unity Search. On the surface, Unity Search is a really cool idea. It covers a key feature, that search anywhere command palette we use in most IDEs and other tools. But in practice, it falls really short of at least my use cases, and I haven't seen a team use it much at all. So it's a stereotypical tested by tech demo problem as far as I'm concerned. It works great in tests and marketing demos, but fundamentally, it's kind of rubbish when you actually throw at anything moderately sized, especially like if you start typing in the main search and you've got a scene open that's got art assets in it, you're not going to see the thing you're after. And fundamentally, it doesn't work as the core jump to tool that we use in other packages. So the specifics are that it requires you to push a hotkey and then type out a text filter or tab to the particular provider that you want in order to filter it to the searches, like to the items that you're actually after. And then it also misses a really important critical use case for me, which is I want to select components in my selected game object or game objects or game objects and children. And I want to pre-fill that list so that I don't have to browse through the inspector. And look, Unity features get a couple of updates, then they go quiet. I don't have any faith that this thing is going to get the sort of features I'm after anytime soon. So we need to fix it ourselves, and this talk is about the fucking fix-it approach. So let's just get into this part. So, oops. So the easy part of this, okay, so the first two parts I need for this are really just, wait a second. I need independent hotkeys for all of the primary searches I use. Actually in this talk I've missed adding in one for the menu, but it's going to be trivial to add that. And I also need to make that specialized search about a pre-filled list for game objects and prefabs, and we'll get to that one after. So the easy part, adding extra shortcuts. Honestly, you could just go into the Shortcuts tab, and there are shortcut bindings for these. They just don't have default hotkeys. You could add them yourself, but we want our entire team to be able to access them, so we're just going to script those in so they're added on load if they're not there. Now, one thing is this talk is entirely 2020 onwards, so we're going to have a bunch of stuff that's version different, and we're going to have ifs in the code for handling stuff that is one version or another, and I'll explain them as we go, but just get used to that. And importantly, if you have to do this yourself, the Unity documentation is kind of the best tool to know which version you need to if on, because if you look at a function and in one version it doesn't exist and in another version it does, you go to the page for that function and bring down the versions list on the side of the bar, on the side of the web page, and it will literally tell you which versions have a page for this function. If it doesn't exist, it was probably in the private API or didn't exist before this point in time. So, adding shortcuts through code. This is going to be relatively simple. It's small text up there. I'm going to break it down. Basically, you have an initialize on load method that is going to call, basically add some shortcuts, and we're going to make a quick function that adds that for us. So this is a function, rebind if missing. It's really simple. It just uses the shortcut manager, grabs the binding for a particular binding string, and then checks if there's any keys against it. If there isn't, it just writes something to the log to say, hey, I'm binding this to this key, and then binds it. And then this is the contents of the initialize on load method. because the Unity Search API changed the names of these searches in like where they're in the shortcuts, we have two different versions. So we're binding the same shortcuts for them. So the project and assets and hierarchy are just going Alt-Shift-P, Alt-Shift-H, and by putting this in, if Unity boots up, there's no hotkeys for these. They automatically get bound to those keys. Really nice and simple. So secondly, yeah, we're back to this problem of Unity only builds features for their tech demos. The really frustrating thing is we already have a search for the hierarchy. We already have a search for the project window. There's little things that both of those little filter boxes. And even there was a menu search that already existed on Mac. I think it was Alt ? Or something like that, and you can just search through the menu. But the one that I really need is that jump to member equivalent. Something like, find me something on this game object. And as I keep rattling on, this is what it should look like. I've got a selected game object, I've just hit it, and it's going to give me a list of the components down in the search box before I even start typing anything. As I type, it needs to filter them down. One of the nice things about the Unity search thing is it can show an inspector on the side. That's going to save me moving around and stuff like that. If I hit enter, I want this thing to pop out a locked inspector window for that component. Because the one thing I'm trying to avoid here, I hate when I've got a really big game object, I don't want to scroll through the inspector. So, once again, Unity isn't going to fucking fix this because this feature has kind of gone quiet. But basically, the only way that we seem to be able to get them to pay attention to things again is if you get up on stage and yell about it or post something online. I've got a strong suspicion this is actually why we have mechanism state behaviors. I did something like that many years ago, and then they asked for the source code, and they came up with something similar. So okay, moving right into the actual implementation, well, what do we need to do to make this happen? Well, there's two stages. First of all, we create a new provider, and that's the complicated part. That's the back end where there's an API for you to extend the search window with new types of searches for end users, which is nice, but it's kind of a bit more complicated. It's that new, overly software engineered kind of API that they're using more and more. So it's a little bit frustrating for me personally, but we can use it. The second half is just we're going to bind some shortcuts and make some user interface elements, like some GUI, so that everyone on the team knows this and can use it easily. Okay, so first of all, we're going to start adding a search provider. This is actually going to be quite a bit of code, but not actually that complicated. So this is the first part, and we're just going to break this down. First of all, we just have constant strings. I've been saying one provider. We're actually creating two. We're creating one for get component and one for get component in children. Because they share so much stuff, most of the implementation is going to be shared between them, but we have to define separate IDs, and because we reuse those IDs so often, I'm just making constant strings up there. The way you register them, you create a search item provider method, so search item provider method attribute, and then on a static method, and that returns a search provider. Because we're factorizing these things, because they're basically the same with one or two alterations, we have the same function and just return true or false, and this is that function. Now, the first three lines are just a ternary tuple where I'm basically getting the provider ID, the display name, and the filter ID of the search, depending on whether or not you're doing the in children version or the not. So you're either getting like the provider ID for the get component filter and like the display name, and then the filter ID is like the text. If you brought up the regular search window, what do you need to type before your search in order to actually activate this provider so that you just get specifically that search? After that, the rest of it is just return new search provider, and you just fill it out with details. So it takes essential things in the constructor, but then everything else that we need is actually put in here. And the way it works is most of these things are actually methods. The first couple, like what options and a couple of things like what our filter ID is, those are just fields. But then everything after this is like a coroutine-like method. So, and the really essential ones are fetch items, toObject, and actions. But the other ones I've listed there are really important for quality of life stuff, like start drag, fetch thumbnail, and track selections. And actions is really important, but actions changes between. Actions is what happens if you hit enter on one of these things. You define a list of different like pop-outs that it can do. So We're going to go through all of those methods one by one. ToObject is actually just implemented inline because we're just dealing with components. So we just grab the item as an object, like item.data as an object, that's done. So how do we actually get items? Well, it's relatively simple. So like I said, most of these methods are actually like coroutines. They're not exact coroutines, but they work the same way. They are a method that returns IEnumerable, and you can yield to make it stall for a frame, which is really important because a big search could lock up the editor for a while. And the way this works is I just make a giant link query that does what I want, and then I use a simple string split scoring function of my own, and I will grab all the components on the selection of game objects. Actually, easier if I just go through the query one by one. The first thing is just a helper function that I've written, which is in the code if you need to see it. It basically just gets the selected game objects. And then the second one is, if this is an in-children search, it calls get components in children on all of them. Otherwise, it's just get component. The distinct is actually probably unnecessary. I'm not sure why I put it there. I do a quick null check just because there's an edge case where this item probably could be null. And then after that, I am going, I grab the path, and then I run the scoring function on them, unless it's a blank search, in which case everything passes. And the scoring works where all the items get put into the search box in the order of lowest score first. My scoring function works the other way, so when I create the item, I do negative score. And I just create the search item. And that query isn't then put to an array. What I do is I just loop this query one step at a time, and then I return it to the items array, which is like where your finished items go as it's done. And this function gets, like, coroutine gets terminated and restarted anytime someone changes their search text. So this will work just fine like this. It'll change its filter as you go. So very nice. The scoring approach is really simple. It looks more complicated than it is. Basically, like I said, I split the search string at the very start, and then after, so I split it on white space, you end up with like every single substring of like every single word in the search text as another word, and then I search through the type name of all the components and also the game object name of all the components for those words, those substrings, and then I score them by the length of those words. And if a word matches inside the type name, I give it 5 points per character, and if it matches inside the game object name, I give it 1 point per character, and that's just a nice rounding thing that works for me. If you want to change that, do it yourself. This kind of thing is very, very simple. We will reuse this stuff later. Adding an open item action. This is really simple. There's basically just a function for opening a property editor in the new version of Unity that's public APIs. So editor GUI utility.property editor, and you pass in the object. And this is the open item thing that we bound as our only action in the search provider above. And then this function was private or internal in previous versions. So it still exists, we just call it by reflection. We get the type by the name, we get the method from the type by the name, and then we just invoke it by reflection. So those two if-def versions are exactly the same. One of them we're supposed to have access to it, one of them we're not, but we don't care. Okay, so like I said, registering actions in the new version is done in that when you build the search provider. In the old version, it was done with a separate method attribute. So to do this, you go and we have a static function, which is search actions provider. It returns an enumerable of search actions. So what we do is we create the same search action for both of our providers here. So we just return an array of search actions, one for get component ID, one for get component provider ID, and one for component children provider ID. And yeah, they just call that function we saw before. And this is only for the old version. So if you're 2021 or newer, don't do it this way. You do it the other way. I think I'm getting echo from this mic, sorry. Okay, so this is, I said I was skipping the fetch thumbnails section. I am, but I'm including the get icons function just because this is the most useful function that I keep using since like forever. This mimics how Unity gets their icons for the project window, the hierarchy window, and things like that. So feel free to steal this code. It basically works like this. Anything that supports custom icons, or there's a bunch of types that do, we call editor GUI utility to get icon for object. So that'll give us, if we get that, cool, that's our icon. If we don't have, it's not one of those, if it's a script, scripts have a special icon that you look up by its name. And then if we have a fallback, if we can't find any icon those ways, we use editor GUI utility dot object content and get the image from that. And that's sort of the default case fall through that they use. Again, in 2021.1 and newer, that get icon for object function is public, so we call it one way. In previous versions, it was not, so we're calling that one by reflection. And we don't call this function that often, so it's fine to just call it by reflection without caching it. Keyboard shortcuts. So at this point, we've covered the bases. The search window will work, but we can only access it by opening up the primary search window and writing in our filter text. So let's just add in some shortcuts that fire up the search window locked to our provider only. So the first half of this is really simple. Once again, method attributes. So the shortcut method attribute, and once again, both of these things are going to be almost the same, so we factorize them into one function and just call them with stubs. Basically, it's shortcut, what the path is that it's going to appear in the shortcut window, and then what your default keys are for it, and then called function. And then this is our function for open as quick search. Bool is an include children's version. We only do this if you have an active game object, or that helper function I mentioned earlier works for if you're in a prefab, it will pick the prefab stage route if nothing else is selected. And then this is where the API changes quite a lot. In the new search API, it's a little bit frustrating. It's a lot more complicated. There's some nice new options, but you have to go and create a custom search context and pass in a new instance of your provider. At least that's the way I've found to do it. You pass in various options. You create a search state and then specify the window's position and width. Otherwise, I found some problems there. And then give the window a title and show it. The old way I liked a lot better. I just call quicksearch.open contextual providers, open with contextual provider, and then I just pass in a list of the provider names, and it just seemed to work. The only downside of the old version was it was hard-coded to not show any items if you had like a fully blank string, so it just added a space in there. I mean, anything works. We're doing crimes here, so. Okay, so that's fantastic. As far as my use case is concerned, that's golden. I don't need any more. But I want my team to use this. And if I go, hey guys, I had made this fantastic tool, post this on Slack, no one's going to remember what the hotkeys are. It's just never going to get used. So let's just put this where they can't possibly miss it on the top of the inspector. So we're going to be doing this a lot in this talk. We have yet another initialize unload method that's going to bind the editor.finished default header GUI function. This is that the bottom of the inspector, so the top of the inspector just below sort of the title in the prefab line. And this is where they either draw like the addressables button and stuff like that. And we can just draw anything we want in there. So this is that GUI function, and it's really simple. We're just going to put two horizontally spaced buttons. One is search components, and the other is search components in children. And if you click one of these, what it's going to do is change the selected objects to the objects that this inspector is currently targeted at, and then call that open quick search function that we bound to the hotkeys, and then put the selection back. That's it. And that means that at the top of the inspector, there will be just two buttons under your addressables button, if you've got it there, for search this inspector for components. Really, really nice stuff. So we've done that. I'm not going to do a live demo because we're so short on time. We're going to basically feel free to play with it in the code and things like that. There's a full project there. So, all right. So let's actually get into doing some horrible things. Oh no, unless you've actually spoken to me about this talk. We're in for some fun. So this is, the common theme in this talk is, we're after things we're not supposed to have access to, or at least they're not in the public API. And while we have access to the source code of Unity's packages, like stuff that came in through the package manager, we can't really see the internal and private contents of stuff that's been built into DLLs, like unityeditor.dll or unityengine.dll. Nah, full debug symbols, modern disassemblers, we can see everything. Like, I can show people disassembled source code, and unless they know the telltale signs to look for, most people don't know that they're looking at disassembly. So talking about disassemblers, most people know about ILSpy. I personally prefer .peek. I find that it actually gives some better results, but personal preference as you see fit. If you use Writer, it has .peek built in for any assemblies that it's referencing that it doesn't have source code for. So that's really easy to do. I'll try to keep my voice down. I can hear the echoing, the ringing. I'll explain how to use .peek and Writer in this talk because I'm most familiar with it. .peek is free, but if you prefer any others, go for it. So how do you set this up? Well, basically open up .peek, grab the Unity editor and Unity engine.dlls from your Unity install path, and just drag them into the project, like into the sidebar, or you can just file open them. In Writer, if you just open a Unity project, it's ready to go. And then it works just like an IDE. You press Control-T to do a full project-wide symbol search. And it's F12 or Control-Click to go from any symbol to its definition. If you're at the definition, doing the same will find usages. That's exceptionally useful because we're not into like walking around the code and reading lots of code. We want to jump relative a lot when we're doing this. And finally, Alt/ is like you're in a file, like one file in disassembly is generally one class, and it's basically search through the members of this type. That we will use a lot too. So what we're going to do is we're going to start disassembly diving. I sometimes call it drilling. I'm not good at naming things. So we've basically got the full access to Unity's managed source code, but there's too much for us to just jump in and start reading. It's interesting, but it's not going to solve any problems. You need to start by looking for something very specific. Like you've got a problem to solve. You want to try and figure out how to fix a problem or do something that they do, but you can't. And so yeah, the best approach is to say, I need to find the exact line where this is implemented, or the exact function. It's much better than going, oh, I need to know how this whole feature works, because the features are often nebulous. They touch a lot of different places. It can get a bit difficult to find out exactly where everything goes. Finding an exact place they do one thing, really good place to like, good target to be looking for. So you start looking for, thinking of starting points. Basically, you've got the ability to search for classes, methods, names, variables, and to some degree strings. So things you can uncover by name. The user interface is a really good place to start because most things in the user interface, what they look like, which windows they are, things like that, their names match up to that in the code. And some of your starting points will be duds. You're essentially going blind through the code here. It helps to look up to think up new starting points as you go, because if you get stuck on one, you're going to have to just basically find another place to go. So then we start searching through the hits we get on these starting points. Mainly in my case, I'll go for classes and methods first, and then I don't read everything I find in detail. I skim it to get, does this relate to what I'm looking for? If the answer is probably no or remotely no, I get out of there, I go to the next hit, and just keep going through them as quickly as possible, because I'm going to be going through a lot of them most of the time. I've cut down how many I go through in these slides, but yeah, you will be doing this for a while. Really know when to call to quits on a particular starting point, because some of them, as I said, will be duds, and you can spend almost infinite time there. Once you find one that's related to what you're after, go deeper. Basically, if you found something that is being used by the thing you're after, go and find, search its usage. You search its usages. That's a good place to find new starting points. Otherwise, if this thing is instead up the chain, you want to just read its code, go through the methods it calls, start looking through those, and then do the same thing. You want to skim read each of these hits you get and check, does this relate to what I'm doing? Pass it on quickly if it doesn't. Go deeper if it's related. And keep repeating it until either you just run out of time and have to give up, or congrats, you found it. Now this is where the actual work begins. It depends entirely what you want to do with this code. So And what you're trying to do, usually you're either trying to replicate something that they can do or have done and you don't know how to do it, or you're trying to modify it to do something a bit different. Well, copying is generally the best case scenario if you can. Sometimes you can just copy a block of their code from disassembly and just drop it into your own code, and they've only used public API calls, and it will just work. But sometimes you either need to invoke some of the methods they've used. Sometimes you just invoke their whole method, and that works. I've actually done a override of the timeline window where I had my own window, and I called the timeline window's GUI functions from inside my window's GUI functions and played with their variables so that I could draw the whole timeline window's contents inside my window as a tab. Disgusting? Yes. Very useful. Okay, so this is where we get to, what is this talk actually about? If you want to change the way that something is actually done in code, that's trickier. So first pass, check if there's any way to avoid going and doing modification. Maybe you can mess with a variable. Maybe there's a callback that can interact with this somehow. But sometimes there's no way to do it but actually to get in there and change something. And if you must change the contents of the code, there's a way of doing that's far less scary than you think. Runtime assembly patching. Okay, so I'm going to add one quick aside to this. There's a reason that I don't think anyone in this room has seen the approach I'm taking, and that's because I went about this from I do speedrunning in my spare time. I picked up a game. There were no good speedrun tools for it, so I was like, cool. It's an ILT-CPP game. How do I do that? Well, I know Beat Saber has mods, and it's ILT-CPP, so I looked at how they did it. Turns out the RimWorld modding community made this amazing library called Harmony that is just God's blessing for modifying code in a really simple, really elegant, and extensible way. And the way you do it is you just grab the latest release of zeroharmony.dll and just drop it in your project, set it to editor only, and from here on out, you can basically add prefix and postfix code to any method. And prefixes can modify the inputs. They can abort the original function. Postfix code can modify return results. They run afterwards. So prefixes obviously will run before. Postfixes will run after. You can modify return values. And then you can even stack multiple prefixes and postfixes for different things to the same method. You can even modify the original method at the same time. There's like transcoding where it will just give you the IL instructions as an array. You return your modified array of IL instructions, and that becomes the new original method, so to speak, that the patches go around. I've only ever needed to use this once. It's very time consuming. Avoid it if you can, but it's kind of cool. Let's do it. We're just hitting half time. Let's actually do some ripping and tearing. All right, so we want deep links. We want to be able to click a link in the browser and do something in the Unity editor for this. Our goal is to figure out how Unity already does this because the package manager window automatically opens to the right asset when you click an asset store link. So we know it's possible. We also know from the browser that they use the URL prefix, which is com.unity3d.karma. So we've got some starting points. Methods that open the package manager is a good one. Anything that contains the word URL. One that I didn't think of when I was writing these slides, which I'm slapping myself for now, that string, com.unity3d.karma, obviously is a likely candidate to appear in the source code around where this is happening. And we're just hoping that the URL gets passed in by a callback or it's stored somewhere we can read it, but because this is this part of the talk, you know where we're going. Okay, so let's start looking for clues. Well, the best place is that package manager window. So we just open up our disassembly, we simple search for package manager, go down, we find package manager window. And we do a member search, so for any methods that contain the word open, there's like 4 hits, but one of them is called open URL, which is pretty sus. So that's the disassembly for the open URL function. It takes a URL, it then strips a version of like com.unity3d.karma.:upm package off the front. So it's getting our link, the link we want. It gets the full link and uses it to open the package manager window, but it doesn't store it anywhere. So this is not ideal. So what's calling it? Well, we do a usages search on the URL function, and we find that it's not getting called from anywhere. And this checks out because it has the used by native code attribute on top. And that's what Unity methods have on them when they're being called from the native code layer. So that's a bit of a bind. That means that we can't replicate this code because we're not going to be called by that native code. We're going to have to modify this method so that we steal the URL if it's one we care about, and we let it pass through to the package manager window if it's one we don't care about. So, well, let's do that. Like, this is it. That's all there is to it. As again, breaking this down, I like to, whenever I'm making packages, there's two things. First of all, I should have this on the slide. I put all my patches into one patch per assembly definition, or one kind of hack per assembly def, because when you run patching, you create a new Harmony instance that has an ID on it, which is a reverse domain syntax, that's the standard, and that just says what this one is if you're debugging. And then you call harmony.patchRule, and that will search through your current assembly, and it'll find every single Harmony patch attributed class, and it will try and use that as a patch. So restricting it to one assembly really speeds up this process. So then we have our prefix function and a list of funcs that take a string as a parameter and then return a bool. And we're going to just use that as our listeners. So if anyone wants to listen to the URLs as they come in, we just add a function to that list. And the prefix function itself, so Harmony works by specially named functions and specially named parameters. So you have to look up the documentation for them all, but they're quite simple. Prefix is the one that does prefixes, and it takes whatever your function takes as arguments, plus some extras if you want to use extra features. And we're just going to loop through those listeners. We call it, we just invoke the method, pass in the URL. If the result is true, that listener has used the link, we want to return false. Returning false from a prefix aborts the original method. Otherwise, we get through to the end, we return true, we are allowing the original method to run. The second part of this patch is just the target method. Access tools is just Harmony's super nice and clean reflection helper functions. So we're just really just getting the type and getting the method. And because we have Harmony loaded in this ASM def, we are just using the nice function. So very simple, you just return the method info. And that's it. That code there gives us a little tiny API for stealing links for anything. So let's use it. Let's go and create yet another header for the inspector, where if this thing is an asset, it'll draw the GUID of the asset and a little copy link button. And we're going to make it so, and we'll also register for the link stealer, a function that if you click on a link that has a GUID in it, we will select and ping that asset if it exists. So ideal for you put this link in a bug ticket or something like that. This prefab is fucked, that sort of thing. So this is all of that. First part, as I'm going to make our URL prefix that we're searching for here. So it's the base URL prefix plus select GUID. We then initialize on load method. We will then both add our own on URL patch to the URL patch listeners. And then we also register another GUI header callback. So draw header GUI for this, for that button. The header is really simple. It's just a text box. We only show it if, sorry, no. I got my slides the wrong way around. We're going to do the link first. So this is the function that we're binding to the list of link listeners. We only care about this link if it starts with that prefix we defined above. If it doesn't, we return false. We're not interested in this link. Otherwise, we will grab the GUID from it by just chopping the prefix off it. We then convert that to an asset path. If the path is null or empty, we just write an error, but it's still a link, so we're going to say that we used it. And then if we got a path, we load it, we select it, we ping it. Done. And then the GUI is relatively simple as well. We basically say, okay, if something's selected, if it has an asset path, that means it's an asset, get the GUID and basically draw a disabled text field that draws the GUID, and then a button that basically puts, so GUI utility.system copy buffer is basically the, oh wow, okay, 10 minutes, we're gonna do this fast. So that's basically the clipboard, so we're just gonna paste the URL prefix plus the GUID to that, and then we're gonna end that. Okay, cool, so that wasn't too hard, was it? Because we're gonna break something else. You know, it's really nice in other tools I've been playing around with where you can filter through the inspector and like type a little search field up the top and it just reduces down the options there and it like only shows you ones that match up. Like sometimes you want to find everything that's called rotation on the current game object, or someone's messing with the color or something. You know, you'll find uses once this thing exists. So if only there was some way to have a search box that we have, like the one we have on the project window or the hierarchy window, just on the inspector. And the conventional wisdom is that to do this, you would have to write a full custom inspector, but this is a talk about runtime assembly patching, which we are not doing conventional wisdom here. So what we're after here is basically that little search box at the top, and as I type it in, it just starts deleting anything, like it doesn't delete the component headers, we still want those. We just want to delete all the fields if that don't match up. So there's no way to do this perfectly because custom inspectors exist. So what we're going to do is we're going to do a two-phased approach. The first phase just doesn't draw the inspector contents at all if the search text doesn't match any property in that component. Secondly, we're going to go through and modify it so that the defaultly drawn properties, the ones that we can actually filter on, we will hide those if we can. And so you will basically have one patch for the component draw, one patch for the default property draw. So where do we start? Well, there's a really obvious place because edited on inspector GUI is the function you override when you make a custom inspector. So when it's drawing when it's drawing the inspectors, it's got to be calling that. So that's basically a great start point. So we check it out in the disassembler, and we find that it's calling this function, and that calls a stub, and that calls draw default inspector, and that's interesting. There's a bit of fluff on the start and end, but it's really just looping through all of the fields, like all of the serialized properties in this thing, and calling editor GUI allow.property field on them with include children true. One function. So that gives us two things to go on. First of all, we can kill the whole component by nuking this thing at one of two layers. We could patch draw default inspector, that one there, which is the actual implementation of the default inspector, to nuke what it's drawing if it doesn't match the filter. But that would only work for default inspectors or the sections of inspectors that we haven't drawn custom. Or we could patch every single on-inspector GUI method in the code base for all derived classes to just nuke that function if the filter isn't met, which is exactly what we're going to do. So this is our patch. Well, no, this is the GUI. I'm starting with the GUI for this one, sorry. So the GUI part, we're just going to draw a text field. We're also going to cache the splits of our search string, just because we're going to be using it a lot, and we only want to update that when the GUI updates the string or thereabouts. So it's drawing yet another heady GUI. I don't need to go through that stuff too much. We just got the text box, but there is one sneaky thing. Patch it or patch if needed. I'll cover that just next. But yeah, we just text box, split the white space on it, so we've got that string splits, because we're going to do the same filter test as we did for the scoring. Patch it or patch if needed is funny. Basically, I've got a patcher class, but I'm not calling it an initialize on load. I'm creating the Harmony instance inside a GUI call because many Unity GUI types throw exceptions if they're referenced outside of a GUI call. And Harmony is going to reference everything. So, and also patching has a performance cost. We don't need this patch to run until we're looking at an inspector. So this is a good time for it to happen. So this is our filter function. I'm going to gloss over it because is essentially the scoring function from before without a score. It's basically, do any of the words, the word splits, exist in basically the name of the thing we're looking at, the name of the property? If they do, return true. If none of them do, return false. And then this is the patch. So as I said before, we have our patcher class. I like to keep the patcher separate from the patches. It has a Harmony instance that it keeps. If it already is made, don't remake it. If it isn't made, we create the patch, name it, and call patch_all with it. Our prefix method is relatively simple. We are basically just, we grab the editor, we grab the serialized object that it's looking at, and we just start looping through its properties. And we check the name, the display name of every single property, including their children, as long as they're visible, against our filter using the filter function. And that uses the search splits from the GUI. If any of them pass, cool. Call the inspector GUI function. Otherwise, abort it. And for target methods, rather than specifying a target method, we use target methods. So Harmony has a multiple method patch name thing. You just return a IEnumerable of method base, which are method infos. And I'm just using the access tools functions of the link query here because it's nicer and cleaner. But I'm really just going, give me every single editor in the game which is not abstract, and then from those, give me the onInspector GUI function. Done. And it will do it to all of them. And that's it. For the first phase, if we type in something into the filter and there are no properties in a component that have that in their name, it will just delete the whole GUI, the inspector drawer for that one. It'll keep the header, but everything underneath will be destroyed. But we've got a couple of minutes left, so let's make this better and actually selectively delete properties on the ones that have got them. So fortunately, going back to that thing before, they only use editor GUI layout.property field, and unfortunately there are 4 overloads of this function, but they all point to the same one, this one. And it calls one function, onGUI layout. And this is the thing that does the actual work. This is actually looking up which property handler draws the thing and handles all that stuff. So we know where this thing's happening. We basically got this one for free. But so to filter property, we basically need to nuke this in one of these 2 places. Both of these methods are actually good candidates, but I recommend us filtering on, like patching out editor GUI layout.property field. As it's a public method, it means it's more robust to change. They're not going to change it in versions as often. So it's just going to be, that's a nicer place to put a patch. And so here's the patch. I'm going to kind of gloss over this quickly because short of time, but this is the, rather than specifying target methods in a target method, I'm specifying it in the Harmony patch attribute because these are public items, so it's easy for me to use type of and name of. It's only long because of all those overrides. I have to specify all of the argument types so that it knows which version we want to patch. And the patch is basically the same as the last one. We basically grab the property rather than the serialized object from the editor. We then get the end property for this thing's children, and we just loop through all its children until we get to the end property. And if it passed a filter, we return true. If it didn't match any of them, we return false. And so what happens now is if the first filter doesn't nuke the inspector for this, the GUI for this one, it will then get this one every single time it draws a property, and it will filter them. If the name doesn't match, it will delete that property line. You might have noticed there was a check for active in that patch. This, if not active, return true. That's because property fields used all over the code, all over like the Unity editor. It's not just used for the inspector. We only want it to be active in the current inspector. So what we do is we get a bit sneaky. We go back to our previous patch and we add into the property field patch, just before we return true, we set property field patch.active to true. That basically turns on the property field patch, or otherwise it always passes. And then we create a postfix method that turns it off. So it's only active when you're in the inspector for something that has already passed this other check. So final tweaks. We've got it working now. It's done. The only one last thing is currently our text area is that default Unity text area, and no one's going to recognize that as a search box. There is an editor GUI layout toolbar search field, but it's internal. But I mean, that's not going to stop us. So because we call that this one really often, I'm just going to do a bit of extra thing. I'm going to create a wrapper function around it, and I'm going to cache off the method info for it. That will significantly reduce the call cost of it, but it still costs a bit, but we're not doing the lookup every time. And then we change the header GUI to call that search field function instead of the text field. And bam, we now have something that looks exactly like the filter search boxes for everything else in Unity. So hopefully people will recognize it. And yeah, we just did in 15 minutes what Unity couldn't do in 15 years. So. All right. Now, I don't know how we're going for time. Do we have time for questions in the room, or am I going outside? I'm waiting for confirmation from the person at the end.
You can go outside.
Okay. So yeah, if you got questions, because like I literally ran us to the last second, come sit me outside.